Let's start with acute inflammation first. It has three major components through which it works. First is dilation of your small blood vessel that lead to increase in blood flow, and second is increased vascular permeability that will permit the leukocyte to leave the circulation, and third is immigration of leukocyte from the blood vessel to the site of injury and then eliminating the offending agent. We will understand all this one by one. So in acute inflammation, a major role is played by blood vessels. It will go under some changes like increase in flow of blood and increase in vascular permeability. Both are increasing to maximize the movement of leukocyte out of the circulation and into the site of injury. Increased blood flow cause of vasodilation is induced by histamine action on vascular smooth muscles. And this is also responsible for rubor and calor, that is redness and heat. Vasodilation is quickly followed by increase in vascular permeability, and this is the hallmark of acute inflammation. Permeability of vessel is increased by several mechanisms. First and most important is the increase in interendothelial space. As endothelial cells are the cells that line your blood vessels, so when the endothelial cell contracts, the distance between two endothelial cells increases. This space is used by leukocyte to move out of blood vessel, and this lead to leakage of leukocyte. This is caused by histamine, so it will start quickly and end quickly. Second is direct endothelial cell injury that is caused by neutrophil, trauma like burn, and microbes. Endothelial cell will die and detach. That will give space for leukocyte to move out. In this case, it will take several hours to repair the endothelial cell and stop the leakage. Third is our transcytosis. Transcytosis means transport through cell. So to transport through cell, we need something, na? So we need some channels like VEGF, that is vascular endothelial growth factor. VEGF also grow new blood vessel, and as these blood vessels are newly developed, their endothelium are not fully developed. Hence, the leukocyte can easily pass through it. Next is stasis. Let's understand what is stasis. Because of these two factors, that is increased vascular permeability and vasodilation, stasis is happening. Because of this increase in vascular permeability, the plasma is also leaking out of the blood vessels, and this will concentrate the RBC. Also, viscosity of blood increases. To add, because of vasodilation, the diameter of blood vessel is also increases, and this is leading to slower of blood flow, that is called as stasis. Let's now understand how these leukocytes are recruited to the site of inflammation. Important leukocytes for inflammation are those who can phagocytose or eat bacteria, and that is neutrophil and monocyte or macrophage. Journey of leukocyte from the blood vessel to the tissue can be learned as Mara T cop, like Mara through cop, like it's like an encounter through police. Police means cop. So Mara T cop, MRAT COP, Mara T cop. So first M for margination. Margination is the process through which leukocyte will be redistributed to the wall of vessels, and the wall of vessels are also the margins of vessels, hence called margination. My zoology sir in NEET days used to say, "Naam mein hi kaam hai," and same here. Or I think at every other topic, if you relate it with name, learning will become so easy. So let's get back to margination. So why is this happening? Like in normal condition also, RBC is present at the center and WBC is present at the margins. Because of stasis, blood flow slows down and more RBC at center displaces more WBC to the margins. Next is R for rolling. So this WBC at the margin starts to attach with the endothelium, detach and bind again. So it starts rolling. This attachment of WBC to the endothelium is mediated by complement adhesion molecule like selectin and integrin, and their expression is regulated by cytokines like TNF and interleukin 1. These cytokines are released in response to infection or injury that ensure that WBC are recruited at the site of infection or injury. Rolling is done with the help of selectin, that is of three types: LEAP with the absent A, LEP, L for L-selectin, that is expressed or present on leukocyte, and E for E-selectin, that is present on endothelial cell, E for E, P for P-selectin, that is expressed on platelets and also on endothelium. The TNF and interleukin 1 act on nearby endothelial cell and express selectin. Histamine do redistribution of P-selectin from WPB, that is Weber palette body. It is then stored inside endothelial cell to cell surface. So it is like taking out P-selectin from its door and distributing it to the surface. Leukocyte have L-selectin, L for L, so it expresses it, and also has ligand for other two, that is E and B-selectin. These are low affinity interaction or less love interaction, so it is easily disrupted by blood flow. Or like other girl came in and relationship ends. So bind, detach and bind, like break up, patch up and break up, and finally a strong patch up that is like true love. And this is the one next, that is A for adhesion. That is mediated by integrin. As the name tells itself, integrin means it will integrate both of them strongly. Integrins are of two types, beta 1 and beta 2. Beta 1 will bind VCAM and beta 2 will bind ICAM. VCAM means vascularized cell adhesion molecule and ICAM means intercellular adhesion molecule. Beta 1 is also called as VLA4 and beta 2 also called as LFA1 or MAC1, like Mac of your MacBook. Like in normal condition also, integrin is present on leukocyte but in low affinity state, and its ligand is not present on endothelium. But when chemokines come into play, the affinity increases to a high affinity state and its ligand is expressed on endothelium. Now leukocyte will strongly bind to endothelium and stop rolling, and all this is happening at the site of inflammation. So now leukocyte will move out to endothelium, and that is our next step, that is T for transmigration or diapedesis. It occurs mostly in post-capillary venule. WBC will migrate to the interendothelial cell to the site of injury as directed by chemokines. Chemokine is the one that is leading him towards the site. Now leukocyte is out of blood circulation and into the tissue. And here comes our next step, that is C for chemotaxis. In chemotaxis, WBC will move towards the site of injury in the tissue. Chemoattractant that will attract leukocyte is both exogenous and endogenous. Exogenous is from outside, that is the bacteria and the toxin, and endogenous is produced inside, like chemokines, interleukin 1, leukotriene beta 4, and C5a of complement system. And next is O for opsonization and O for optional. This step is optional. Efficiency of phagocytosis, that is our next step, is increased when bacteria is opsonized with opsonin protein. And this is just like making your food tasty to eat. We are making the bacteria for the leukocyte tastier to eat so that it will phagocytosis easily, because tasty food is easy to eat now. Major opsonins are IgG antibody and C3b, that is a complement protein. And here comes our last step, that is phagocytosis. This is a 3-step process in which WBC will first recognize and attach to bacteria to be ingested. Second is engulfment, in which bacteria will bind to the receptor, that is the phagocyte receptor. Then pseudopodia will surround the bacteria. Then phagocytosis of bacteria into phagosome. The phagosome will now fuse with lysosome to form phagolysosome. And last is the killing by reactive oxygen species or nitric oxide or lysosomal enzyme. Let's first see how reactive oxygen species kill the bacteria. NADPH oxidase, as the name says, it will oxidize NADPH to NADP+, and in counter reduce oxygen to superoxide anion, that is O2-. O2- will now be converted to H2O2 by superoxide dismutase. Then this H2O2 will be converted to HOCl by myeloperoxidase in the presence of a halide like Cl-. HOCl is an antimicrobial agent that will kill the bacteria by halogenation, in which halide will bound to the cellular component covalently, and also the oxidation of protein and lipid. This is H2O2 MPO halide system. Next is killing by nitric oxide. Nitric oxide is produced by arginase by enzyme nitric oxide synthase. So as the name says, it will produce nitric oxide. NO will react with superoxide from the MPO halide system to generate highly reactive peroxynitrile, that is O and NO-. This attack and damage lipid, protein, nucleic acid of microbe. Killing can also happen by other lysosomal enzyme also, like lactoferrin, defensin, lysozyme. And there is some other type of killing also, like NETs, that is neutrophil extracellular trap. As the name says itself, it is an extracellular trap made up of nuclear chromatin of neutrophil to kill bacteria. And in this, obviously the nuclei of neutrophil will be lost, and as the neutrophil lost, it will die. NET contain a high amount of antimicrobial substance at the site of infection and prevent the spread of microbe by trapping them inside the fibrils and finally killing them. One more is frustrated phagocytosis, It happens when leukocyte become frustrated because it is not being able to ingest or eat immune complex as it is stick to the basement membrane. So in frustration, it releases a lot of lysosomal enzyme to kill it. Like a hungry, angry man who is trying to eat food but not able to do so because the food is stick to the plate. So in frustration, he splits a lot of saliva on the plate.